Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the oblique lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. An oblique line is the one which happens to be inclined to both the reference planes, that is horizontal plane, as well as the vertical plane. In case of oblique lines, neither of the front view or the top views, they will be parallel to the XY reference line. And in case of oblique lines, the projections on horizontal plane and the vertical plane will reveal the apparent length of the line, and we will not be able to observe the true length of the line in the front view and the top view orthographic projection. So in case we are required to evaluate the true length of the line, then we have to use the principle of the rotation of the line in order to obtain the true length as well as true inclinations of the line with respect to the reference planes HP and VP. Here we have been provided with the real world situation in which two flowers A and B, so they are located within a rectangular compound wall whose P and Q surfaces, they are meeting at 90 degrees. So here we can see that this is the wall P of a compound, this is the wall Q of a compound, and these two walls of a compound, they happen to lie at an angle of 90 degree. Now we have been provided with the coordinate location of these two objects or the flowers. So here the coordinate location of the object A or the flower A is 1.5 meter above the ground. We can see this distance above the ground happens to be 1.5 meters, whereas the flower A, it is located at a distance of 1.5 meters away from the wall P. So this is the wall P. Flower A is located 1.5 meter in front of the wall P, whereas the coordinate location of flower A with respect to wall Q is 1 meter in front of the wall Q. So here we have been provided with all the three coordinate locations corresponding to the point A or the flower A, that is 1.5 meter above the ground, 1.5 meter in front of the wall P, and 1 meter in front of the wall Q. Whereas in case of flower B, the coordinate locations happen to be like this, that is flower B, it is located at a height of 3.5 meters above the ground, and flower B, it is available at a distance of 3.5 meters in front of the wall P and 5.5 meters in front of the wall Q. So all the three X, Y and Z coordinate locations corresponding to the flower B, they are also available with us. So using this real life data over here, we are required to convert this real life problem into the orthographic projections of the oblique lines, and we are going to evaluate the front view projections, the top view projections of these two objects or the points which are located in the space. And once we are able to draw the orthographic projections, thereafter we will be evaluating the true length of the distance between the points A and the point B in the space, and we will be evaluating the true inclinations of this true length with respect to the two reference planes, that is horizontal plane and the vertical plane. So this is the spatial or 3D representation of these two objects. Now we are going to have the 2D representation as well. So we can see that in case of 2D representation, so this is our wall P and this is our wall Q, and through this point we are going to look at this particular environment from the front view. So as we know that point A or the flower A, it is located at a distance of 1.5 meters. We can see This is the distance 1.5 meters from the wall P and 1 meter from the wall Q. So this distance is 1 meter from the wall Q, 1.5 meters from the wall P, and the height at which this object A or the flower A, it is available with us in the spatial world, it is 1.5 meter above the ground. Similarly, point B or the flower B, it is located 3.5 meters in front of the wall P and 5.5 meters in front of the wall Q, and this is located at a height of 3.5 meters above the ground. So with this information, we are going to evaluate the true length of the distance between the points A and B and the true inclinations of this true length from the reference planes HP and VP. So let us first of all proceed with the construction of the orthographic projections of these two objects in the space. So here we have got the XY reference line. Now we know that in the front view we are going to get these 2 points, that is point A and point B. So point A, it is lying 1 meter from this particular wall Q. So first of all, what we have done, as we are going to look at these two objects from the front view in this orientation, so we are going to get wall Q will be represented in the orthographic projections like this. Now we know that this point A or the flower A, it is available with us at a height of 1.5 meter above the ground and 1 meter distance away from the wall Q. So these two coordinates in the orthographic projections will be giving us the front view location of the point A dash in the space. So we have drawn a height of 1.5 meter above the ground, which we are going to get with a scale of 1:50. So 1 meter we are going to draw as 20 millimeter. So here we have got a height of 1.5 meters. So this 1.5 meter will be represented in the orthographic projections as 30 millimeter. Now this is the height of the flower A above the ground. Now we also know that the distance of this particular point A or the flower A from the wall Q, it is equal to 1 meter. So this distance we have marked as 20 millimeter over here. So corresponding to these two dimensions, we have been able to obtain the coordinate location of the point A, that is A dash, in the front view projections. And we also know that wherever we have located this point A dash in the orthographic projections onto the same vertical projection line, we are going to obtain the location of the point A in the top view projections over here. Now we also know that the height of the flower B or the object B in the space is 3.5 meters above the ground. So 3.5 meters means that 70 millimeter above the ground. Again, we have marked the locus line corresponding to the point B. That is, onto this locus line, the front view projection of the point B or the flower B will be obtained over here. Now once we know that A dash is located over here, so we can locate the coordinate location of the point A when we are able to draw this particular wall. So please check, once we draw this wall P, so we know that this is the top view of the wall P over here. So wall P once we locate, so we know that the distance between wall P and the point A or the flower A, it is 1.5 meters. So we know that the distance of the flower A from the wall P happens to be 1.5 meters. So we must mark over here the distance of 1.5 meters between the wall P and the coordinate location of the point A in the plan. So once we have marked this location of the wall P over here. So we are going to measure this distance of 30 millimeter, that is equivalent to 1.5 meters over here. So we will be able to get the coordinate location of the point A. So A dash has been located in orthographic projections. The plan projection corresponding to the flower A or the object A, it has also been located in the orthographic projections over here. And another thing we know in this particular case, that this is the point B. So point B or the flower B, it is located at a distance of 3.5 meters. We can check it out over here. 3.5 meters in front of the wall P. So we have drawn the wall P over here. So wall P, once we mark it out over here in the plan, now we are going to mark a distance of 70 millimeter, which is equivalent to 3.5 meters in the plan. So in the top view, this distance becomes 70 millimeter or 3.5 meters over here. So once we mark this distance, now we are going to draw a construction line which will be corresponding to the location of top view of the point B. So top view of the point B means that this flower B or the object B will be lying 3.5 meters in front of the wall P, as we are going to look at this object from the top view. So this distance we know, that is 3.5 meters. And in order to fix the coordinate location corresponding to the point B, we also know that the distance of point B, that is this distance from the wall Q, it happens to be 5.5 meter. So this distance of the point B from the wall Q. So here we have got the wall Q. So wall Q we have marked over here. We have also marked the distance of this point B from the wall P. Now since we also know that the distance of the point B or the flower B from the wall Q, it happens to be 5.5 meters. So I can mark a distance of 110 millimeter, that is corresponding to 5.5 meters. So now I know that I have already drawn a distance of 3.5 meters from the wall P. I have also marked the distance of 5.5 meters from the wall Q. So wherever these two locus lines they intersect, I will be getting the location of the point B in the top view projections over here. So point A has been marked in the top view projections, that is 1 meter from the wall Q, 1.5 meters from the wall P. Similarly, the location of the point B has also been marked, that is 3.5 meters from the wall P, 5.5 meters from the wall Q over here. So points A and B corresponding to the top view projections, they have been marked. And once I mark this point B, so I also know that the B dash projections corresponding to the front view, they will be available with me across this particular vertical projection line. And I also know that the height at which the flower B, it is available with us in space, it is 3.5 meters above the ground. That is, onto this locus line 70 millimeter above the ground, I will be able to locate the point B dash over here. So point B dash has also been located with this information. So A dash has been located, B dash has been located, A and B. So the front view projections I need to join, and I also need to join the top view projections over here. So we can check, we have joined these projections with black line, which represent the apparent length projections of this particular string, which is going to join flower A and flower B. And these are apparent length projections which we have been able to obtain. So this way we have been able to convert this real life problem into the orthographic projections of the oblique line. So here we can observe that the front view projections, that is A dash B dash, and the top view projections AB, so they are inclined to the XY reference line. So we are going to get the apparent length projections in the front view as well as in the top view. Now, having obtained these orthographic front view as well as the top view projections, now we will be using the fundamentals of rotation of the line to obtain the true length of the projections between A and point B over here. So we know that as per the principles of rotation of the line, whenever our apparent length projections of the plan, so this is the apparent length projection of the 2 points A and B in the plan corresponding to the line AB. So whenever these projections in the plan, they are parallel to the vertical plane. So on the vertical plane, if we draw projections through these 2 points, we are going to obtain the true length of the line in the front view or on the vertical plane. But here we have got our apparent length AB, which happens to be inclined to the vertical plane. So what we need to do? We need to rotate this apparent length and make this apparent length projection parallel to the vertical plane. So what we are going to do over here, through point A, we are going to rotate this apparent length AB up to the locus line of the point A. So this is the locus line of the point A. So we are going to rotate this projection line AB. So our needle point will be point A. Will open compass up to the radius AB and then rotate this apparent length to make it parallel to the vertical plane. So now the new apparent length that we have got, it is AB1. So this point of intersection of this curve and the horizontal locus line through this point A, it is giving us the point B1. Now once our apparent length has become parallel to the vertical plane, so through these 2 points, we are going to draw the vertical projector lines to meet at vertical plane. So through B1, we can see now we are going to draw the vertical projector line upward, extended till it meets the horizontal locus line passing through the point B dash over here. So this is the horizontal locus line passing through the point B dash. So wherever this vertical projector, when extended, it meets the horizontal projector line passing through the point B dash. So we obtain the point B1 dash over here. So once we obtain B1 dash, now we are going to join A dash with B1 dash. And we have drawn this projector line with blue color, indicating that this is the true length which we have been able to obtain. So we have distinguished this true length from the apparent length by changing the color of the line over here. So having obtained this true length, now we can also observe the angle of inclination of this true length with respect to the horizontal plane. So this angle has been marked over here as angle theta. Now once we have evaluated the true length of the line in the elevation and the true inclination of this line in the front view, that is with respect to the horizontal plane, now in the second phase we are going to evaluate the true length as well as the true inclination of the line in the plan. So in order to evaluate this, now we have to use this fundamental of the rotation of the line, that is whenever our elevation projection or the apparent length, it becomes parallel to the horizontal plane. So we are going to draw the projectors through these 2 points onto the horizontal plane, and we will be obtaining the true length of the line in the top view or onto the horizontal plane. But once again, our projector line in elevation, that is A dash B dash, it happens to be inclined to the horizontal plane. So what we are going to do? So as usual, we are going to rotate this inclined projector line of elevation A dash B dash to make it parallel to the horizontal plane. So here we have got our needle point of the compass available at point A dash. We'll open the compass equal to the radius A dash B dash and rotate it through point B dash over here up to the locus line corresponding to the point A dash, such that this projector A dash B dash, it becomes parallel to the horizontal plane over here. So we are going to get the second point of intersection over here, and the name of this point of intersection of this curve and the horizontal locus line through this point A dash as B2 dash. So once we obtain this point B2 dash, it means that we have been able to obtain our apparent length elevation projection A dash B2 dash parallel to the horizontal plane. Now we are going to extend this vertical projector through this point B2 dash into the horizontal plane up to the locus line of the point B. So this is the horizontal locus line which is passing through the point B. So through B2 dash, once again you can check the direction. We have drawn this vertical projector line such that it is extended up to the horizontal locus line corresponding to the point B. So wherever these two projector lines they intersect, over here we have got the point B2 in the plan. So once we obtain this point B2 in the plan, we have joined A with B2. Again we have used blue color because this is the true length, and once we mark the true length over here, the true inclination of this true length in the plan with respect to the vertical plane has also been evaluated. So with this we have been able to evaluate true length of the line in the plan, that is A dash B1 dash, alongside its inclination with the horizontal plane. Similarly, we have been able to evaluate true length of the line in the plan, that is AB2, along with the inclination of this true length of the line with respect to the vertical plane, and this angle has been marked as angle phi. And as a cross check that we have followed the principles of the rotation of the line appropriately and our solution is correct. Now we need to check that the true length which we have obtained in the elevation, that is A dash B1 dash, it must be equal to the true length of the line which has been obtained in the plan, which is equal to AB2 distance. So if these two blue lines, that is A dash B1 dash and AB2, if these two distances they work out to be the same, it means that we have been successful in evaluating the true distance between points A and point B in the space. So which are going to represent two flowers, flower A and flower B, for which the coordinate locations they were provided to us earlier. This way we have been able to convert the real life situation into the orthographic projections of the oblique lines, and we have been able to represent graphically the locations of the true length of the line in the front view as well as in the top view, and also evaluated the true inclinations of this true length with respect to the two reference plane. So this is all for today. So we will be continuing with further discussion regarding few more applications of the projections of the oblique lines in the coming lectures. So thank you very much. Thanks a lot.